Hello everyone, recently I was watching a Scott Manley video on antimatter rockets when a certain concept caught my eye. There was this clip that he used of this puppy, and this is a Sunbird spacecraft strapped to the side of Starship. Now, I apparently had missed this idea. It had come out in 2025, and I have some questions. Now that I know a little bit more about far future technologies, we've got this sort of Cybertruck styled module here, and let's take a look at their website. Scott Manley doesn't really discuss it in that video. Maybe he's done a previous video on it because he sort of assumed that we would know what it was, but I had missed that video, I guess. So this is the website of Pulsar Fusion, and let me make sure I've not got it cropped there. Okay, cropping was for YouTube. So here, Sunbird, experience Sunbird. There's a whole launch experience. And we've got a little hotspot there. Oh, we've got a bunch of little hotspots. Okay, Hall effect thrusters. So we've got 8 Gen 6 Hall effect thrusters for precise maneuvers between missions. So they need to be electric powered, right? So that's important. And then what we have here, dual direct fusion drive. Okay, deuterium and helium-3 produce aneutronic fusion. Now, deuterium and helium-3 aren't pure aneutronic fusion. They're pretty good, but they're not as good as the proton-boron 11. So they still produce some neutrons, but it's not as bad. So that's good, but it's hard to do because you have to get it to a high energy level and sustain that. Radiation shielding. It's got radiation shielding apparently for its electronics, I suppose. Okay, we'll trust them on that. And then the exhaust diverter. And so this is the nozzle for the plasma. And we're looking for an ISP of 10,000 to 15,000 seconds. It's all fine on the basic math, but there are a few problems here. First of all, the thruster placement meant for defined maneuvers isn't ideal. Let's take a look at the little animation here as it maneuvers around, but really where these thrusters are and the fact that they're not gimbling, they could have differential thrust, but normally with ion thrusters or Hall effect thrusters, you would expect them to be gimbling a lot, and they're not on gimbal bounce, they're fixed as they are right now. But you can probably tell that there's a bigger problem with this vessel. It's got a fusion drive, but it has no visible radiators. Radiation shielding is nice, but you would probably need that for the reactor, and this doesn't provide a shadow shield potentially. So that's somewhat of an issue. It's like this, which is fancy and all, but it really can't look like this. It really can't look like this. Now, this was reported on by CNN back in April of 2025, so I apologize for not noting it at the time, but let's take a look at these photos. So it's got the dual fusion drives like that. One thing we note is that this chassis doesn't exactly show the interface and all that stuff for the electric thrusters. Presumably, these fusion reactors are providing electricity for the ion thrusters, but to do that, they have to be able to deal with heat for a long period of time. And that's not really shown here. So how powerful is the fusion? Well, it's 2 megawatts of power, they say, and I presume that this is electric power. It says as much as 2 megawatts of power to the payloads on arrival. So they're saying that they're going to be able to convert this to electricity, which of course, as far as fusion goes, we haven't really been able to get positive fusion going at all, right? As far as converting it to electricity, the whole point of a direct fusion drive is so that we don't have to convert it to electricity. We can just let the fusion product spew out, and that reduces how much cooling we need, that reduces how much confinement mass we need, because we're talking about confining the ability to generate this electric power for a long period of time. They say long-term source of acceleration, that's true, and for 1,000 kilograms it's fine. Self-sustaining fuel supply. Not really. You still need the deuterium and helium-3. It's not self-sustaining. Their demonstration, they say core technology components in 2027. Not really. If they must be ignoring the fact that fusion is sort of a core technology component. So that's a bit of a problem. The phrasing here is a little bit weird. Launching to LEO requires 9.4 kilometers per second. Using Pulsar fusion's DDFD already stationed in orbit allows spacecraft to dock at LEO, skipping the massive delta V cost of escaping Earth's gravity well. It seems to be implying that it's skipping this amount, but they should be a little bit clearer. It's skipping the 3.5 to 3 to 5 or 6 to 10 kilometers per second for the transfer, which is mentioned here. This is somewhat of a repeat of this in better terms. But anyway, we've got long-term source of acceleration. It sure would be. Self-sustaining fuel supply, I don't know why they say that. Can potentially propel a spacecraft with a mass of about 1,000 kilograms to Pluto in 4 years. Possibly. 2 megawatts of power to the payloads when the engine isn't running and if you could cool it. So it says electrical power, and we're going for 10 to 101 newtons with a specific impulse between 10,000 and 15,000 seconds. So that's reasonable, given the megawatts of power. And, you know, it looks like this inside. That's the dual direct fusion drive as far as they're concerned. So what are the objections? The objections are that we can't really package a fusion drive to generate electricity in this small a package at all. It has no way of cooling itself. Its thrusters do not appear well suited to maneuver it, despite their animation. And at the very least, they should try to design the spacecraft. I mean, it's got a lot of potential if it could be done. UK's leading fusion company. Well, I think there'd be some objections from ones that are trying to do fusion electric power. I don't know if they're the leading fusion company. Well, let's look them up maybe. Maybe they're further along in fusion than I think they are. So here on Wiki, we see that they tested their first Hall effect satellite thruster. Always a good thing to do. And then also hybrid polyethylene nitrous oxide launch rocket engines in 2021. Working on nuclear fusion powered rocket, but I don't know if they've gotten anywhere with that. As far as UK's leading fusion people, maybe this Britain's Tokamak Energy working with a US fusion company to do it would be a possibility. UK Infinity Fusion Consortium combines Type 1 Energy's 400 megawatt electric Infinity 2 accelerator fusion power plant design, etc., etc., etc. I was thinking more along these lines. Yeah, so Sunbird. I mean, I think what I'm going to do with this, I mean, I wish them the best, but they should probably put some radiators on. And I think I'm going to redesign the Sunbird. I'm going to redesign the Sunbird so it can actually work. So we'll see about that in coming videos. I'll try and come up with a design for this kind of thing that would actually do the job. How about that? And they can take it. They can go ahead and run with it if they'd like, create a new animation for themselves. So the long and short of it is I'm not sold on the little space Cybertruck as it is shown right now. They've done a lot of little videos and created a lot of fancy images of this particular format, but well, they're just missing some critical things. And one of them is the sheer size of fusion as it currently is. And probably the best thing to do is to make sure that it's just direct fusion and not trying to generate electricity. But even then, that would be a huge obstacle and not so easy. But at least if it really was direct fusion, it says, I mean, it's a direct fusion drive until they start generating electric power to run the thrusters. then it's not direct fusion anymore. So yeah, still, it's quite a challenge. I wish them all the best, but questions need to be answered, and maybe I'll try and figure it out in a greater detail. And nobody's gonna give me any funding for it. What can I say? With that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.